Okay, we have seen the topic that is our Earth here. What it is, it is a pale blue dot we have seen, which is captured by Carl Sagan. And we have seen Earth is a storehouse of many resources, right? It gives what we need. So it is a storehouse of minerals that also we have seen. Our reckless exploitation have created many environmental problems on the earth. Then after we have seen the problems created by us, global warming, pollution, deforestation, that is desertification, climate change, and burning of the forest. This we have seen. Then after we have seen how is our universe started, especially focusing to Big Bang theory. Big Bang theory. కాల్ చేస్తే చెప్పు క్లాస్లో ఉన్నా అని చెప్పు డాడీకి డాడీ కాల్ చేస్తాను డాడీ so it is Big Bang theory we have seen some 13.7 billion years ago this created. And here we have seen the two theories. Geocentric theory proposed by Ptolemy. He said that Earth is the center of the universe. That was a wrong theory. Next, heliocentric theory proposed by Copernicus. We have seen that Sun is the center of the universe. It is the truth, right? Then we have seen some ancient Indian books 3000 years ago shown the information related to the eclipse space in Vedanta Jyotisham, Surya Siddhartha, Siddhanta, Surya Siddhanta, and Bhagavata Purana. These are some of the ancient books that also we have seen. So, what is the Big Bang theory? Said universe itself started some 13.7 years ago. Galaxies formed from it, stars, then planets. From the planets, life has started. So, it is a theory said uh, theory of the Big Bang, right? Human beings started there. That also we have seen. Next, we have reached this place. That is, how is the shape of the Earth orbit? This also we have studied, right? What is the shape of the Earth's orbit? Is it in a circular form or oval path or elongated or what you call scaled oval path? So, what is the actual path of the Earth, Earth's orbit, right? So, this we have seen it is not truth because we have to get only one season. It is not occurring, so it's wrong. Then if it is the oval path, then we should get two times summer and two times winter, so it is also wrong. Then we have come to scaled oval path. If you measure what you call the distance between the sun and the earth at two different places, at one point we get the distance of 152 millions. That is the farthest position. And at another point there will get 147 million kilometers. That is the closest point from the sun. So here these are the what you call two important points. We see two important positions. One is farthest position, 152 million kilometers from the sun, and another is 147 million kilometers, that is the closest point. Earth travels around the sun at a speed of 1,07,200 kilometers per hour. 1,07,200 kilometers. On the bike, we may travel with a speed of 60 or 80. Then think the speed of the earth per hour, 1,07,200 kilometers per hour. And like that, it travels 24 hours. That is, it takes 365 1 by 4th days to complete one revolution. The rotation of the movement of the earth around the sun is called revolution. That we have seen what to call in lower classes. So there are two uh, movements to the earth that also we have seen. One is rotation and revolution, right? Next, we will move to the what to call another topic, that how the earth evolved here, right? It is uh, slide showing you that earth was constantly heated with some rocks and other materials coming from the outer space. Most scientists are of the view that 4.5 billion years ago, Earth started forming. Here you'll see that in the initial stage, 4.5 years ago, Earth started forming. At that time, it was a fireball. Earth began its journey with a fireball, a ball of fire, and that ball of fire swirling with dust and clouds passed through the molten stage. Molten stage in the sense somewhat clay, you know, it's not thickest thick soup like that. So molten in the sense it's also hot, it's a very hot stage. So it was very hot and constantly heated with rocks, bombarded by the rocks and other substances of the space coming from the outer space, and it passed through the several stages. As the rocks heated to the earth or bombarded to the earth, its size grew, its size increased. When the material heated to the earth, with that the earth size regularly gone for constantly has gone for growing up, and it gone through the what another stage, that is ice. So later it has taken some millions of years for rains. So here you can see that it is bombarded by other materials onto the earth instead. So it has come to the present shape. How the earth is at a present shape, this is the present shape of the earth, which have come from several stages. That is, one's first stage is a fireball, and second stage is that a mountain stage. Then after pass it through the rains for a million years. Okay, then it becomes slowly cool. So when it was heated with many rocks from the outer space like this, its a size grown up, and the heavy substances which heated the earth, they have gone to the bottom of the earth. That means inside the earth. Okay, inside the earth, they have gone. Like how we, you know, when you boil the milk, you will see that a thick layer is formed, a thin layer is formed on the top of the milk, right? So like that only, when in its stage of becoming cool, A thin layer is formed on the surface of the earth, that what we call crust. It is called crust, which is very light, and the heavier particles or heavier substances, they have gone to the inside the earth, and that is core. In between the core and the crust, this is the core, my dear students. It's very hot here. Hard and heavy substances are there. Then the lighter substances have reached the top of the earth and formed a thin layer, that is a crust. And between the crust and core, there is a hot liquid, that is mantle. So this is the water, the stage of earth evolution. So here it when it passes from the what you call the stage of the cold, it contracted, and the outer crust, the top surface of the earth wrinkled and forming ridges and basins. Later, several gases today what are there on the earth were not present at that time, as it was raining for many millions of years. Several gases have emerged. Then thereafter oxygen also started on this earth. In that way the earth has formed, passing through the different stages. Today we are enjoying this beautiful earth. Then whatever the wrinkles and ridges formed on the surface of the earth, they were filled by water through the rains for millions of years. And today we call them oceans. Large basins filled with water, those are called oceans. And the large, what you call land parts, which are above the ocean parts, are continents. So these are the first order of landforms originated in the process of earth evolution. So what are the primary landforms? That is continents and oceans. They originated in the process of earth evolution. Then after, slowly life started originating in water. That is flora, fauna, plants, animals, and human beings also originated on the earth. Let us see that internal structure of the earth. Earth is consisting of three important layers. One is a crust, which is the topmost layer. Second is the mantle, which is very hot molten form. Then third is the core, which is at inside the earth. And this core again divided into two subparts. One is outer core, this one, and this is inner core. See, we can see that earth has formed from the fireball by the evidence that there is a heart inside the earth still today. Scientists have investigated and analyzed the data to understand the interior of the earth. It is not possible to reach to the center of the earth. Actually, the radius of the earth is approximately 6,000 kilometers. We cannot send pipes up to that one because there is a very hot. So that is enough to say that earth is still active and it has come through the molten stage, and it was a fireball in its initial stages. So going to its three layers. One is a crust, mantle, second one, and third is a core, which is divided into two parts. The crust is the part where we live, where we construct our houses. So this is the what you call crust part with a depth of 100 kilometers. It consists of rocks. Various kinds of rocks are there on the crust part. Next is the mantle, which is 2,900 kilometers depth from 100 kilometers depth. It is from 100 kilometers depth to 2,900 kilometers depth. Understand? It is a pliable layer. Mantle is a pliable layer, which it can there we can find the movements in the crust as it is a molten stage, right? So upon which that is the mantle. Upon the mantle, the crust is flotating. It is flotating like a boat, a ship, a float, what you call flotates on the surface of water. Similarly, the crust also flotating on the mantle. Understand? And this mantle consists of silicates. Silicates are present in a mantle. Then third is a core, which is from 2,900 kilometers to 6,376 kilometers depth. That is a core. And this core divided into two parts, right? One is the outer core. This is the outer core. uh, then this is inner core. Outer core depth is 2,900 kilometers to 5,100 kilometers. And here we find heavy substances like iron and nickel. Iron and nickel is present in what you call core, and the what you call liquid metallic materials also we find in outer core. That is nickel and iron will be in the status of metallic minerals, liquid metallic minerals. The next is inner core. Inner core is from 5,100 kilometers to 6,376 kilometers depth. Here also we find iron components and gold. So interestingly, that the matter from deep inside the mantle shoots up through volcanoes and fissures on ocean floors and cools down to form the earth crust. It means that from the lava from the mantle is erupting out and forming the water volcanoes and fissures on the ocean floors that led to the formation of earth crust. So in many regions on the earth, parts of the earth crust enters into the mantle and once again becomes molten. It means, for example, if you take two things and place on the table, then for example, what you call here, this mantle is very hot, so somewhere we see that in any part of the world this incident will happen regularly. What incident? That is lava erupting from the mantle outside and flowing on the surface of the crust. Due to that hot lava, the crust gets destruction, joins with the water mantle. And at the same time, lava, that is magma, reaches up to the earth's surface. So this is a continuous process. What a destruction of the crust and formation of the crust due to the eruption of a lava from the mantle to the crust. That it's enough to say that earth is still active, right? Because we see that lava coming out and forming what you call the new crust. The old crust dips into the mantle and becomes the part of the mantle. In that process, whatever the minerals present in the mantle and the core will be erupted out, and that will be available in the crust part instead. So the destruction of the crust and becoming the part of the mantle, lava coming out and forming the new crust will say that Earth is still active. The crust upon which we live is still being changed by the earthquakes, volcanoes, and subduction of the land and rises of the mountains. So, due to processes happening deep down inside Earth, as it is molten and very hot, we will find some compression here, and due to that compressional force there the material substances present here will try to come out of this place to reach the earth surface. In that process the crust is always constantly changed. That means earthquakes will occur, volcanoes will form, and the mountains may rise, some other mountains may collapse. This will happen continuously, right? So this is the what internal structure of the earth. The next, moving to the another topic, that is continental drift theory, right? What it is, we may uh, think that the continents are at one place. Generally, it is thought of the people that continents are fixed at one place, but actually there is a movement on the continents. There is movement in the continents and the oceans. They move from one place to another place very slowly. That what we call movements of the earth crust. We just know, we studied, no, that earth crust, right? This, the crust is flotating on the mantle, and it is a pliable layer. Mantle is a pliable layer. What is by pliable? It moves, right? When it moves, on that the crust is there. So what happens to crust? Crust also moves, right? So here, as a, on the crust we find water bodies, then land bodies, that is the continents, oceans, like that. So as the movements are there in the mantle, that movements will be captured by the crust, and crust also starts moving. So the continents and oceans are moving, everything is moving on the earth, but it moves very slowly. That is called your continental drift theory. Today we see the continents are like this, right? Like this is the shape of the earth, and continents are this one today, and it is going to change. It takes a millions of years to get changes in their shapes and the directions. So million years ago the continents were placed at one place like this, and that was called supercontinent Pangea. It was called Pangea instead, and this Pangea surrounded by one large water body, that is Panthalassa. It is what? Panthalassa. Around some 220 million years ago, there is Tethys here, and I'll show you. This is the Tethys. The red line here passing, that is Tethys. So all the continents were at one place some 220 million years ago, and that was called supercontinent Pangaea, and it was surrounded with a large water body, that is a Panthalassa. Inside the supercontinent, there is a Tethys Sea, right? So this Tethys Sea, in that the compressional force generated, and those compressional forces led to breaking this supercontinent into many pieces. Okay, many pieces like this. It broke out. First, it broke out into two pieces. One is Laurasia, another is Gondwana. Laurasia is the part of the supercontinent at the north part, and Gondwana is the part of the supercontinent now at a south side. So this supercontinent Pangaea broke into two pieces initially. One is Laurasia, another is Gondwana, and this two land parts again broke out and turned to several continents. Here you can see that this is African continent, this is South American continent, it is North America, it is Asia, and India. Our India belongs to Gondwana land. So there South America, Africa, and here Madagascar is there, India, Arabia, Malaysia, then East Indies, Australia, Antarctica, all these belongs to Gondwana land, and the continents which belongs to Laurasia, those are North America and Greenland and all of the Eurasia and northern part of the Indian subcontinent. They belongs to Laurasia. So in the Mesozoic era, that is 10 million years ago, the continent started moving. So there is a movement in the continents. This is a theory said by Alfred Wegener. Alfred Wegener, who uh, was a German meteorologist. Alfred Wegener, German meteorologist and geophysicist. He proposed this theory, just know what we discussed, that is, continents are not fixed at a place. The continents are actually moving one place to another place. That is called continental drift theory. As there is drift in the sense movement, so there is a movement in the continents, so that is called continental drift theory. So it took some millions of years for the continents to reach to these present shapes, and even today many of the continents also moving very slowly, and they are pushing each other, and this we will study in the next chapter how they are pushing. Huh? The one point important thing here I want to repeat, that the crust is flotating. The crust, this is the crust is flotating on the liquid mantle, right? So when crust is flotating on the liquid mantle, definitely the continents also will move, and these continents are getting collision with other continents when they come across each other, when they push each other. Due to that, several changes are taking place on the earth surface. So what are that? We'll see in the next one. So here what we discussed that the evolution of the earth, right? It is what to call, earth was initially a fireball. it was bombarded by the rocks coming from the outer space. Those rocks as hitted the earth size has grown, right? Then it passed through the molten stage, very hot one. In the molten stage, whatever the heavy substances hitted the earth, they reached to the depth of the earth inside the earth, and the lighter particles have reached up, right? And then it passed to the another stage, that is rains millions of years. uh, there was continuous rain, and due to that, earth started becoming cool. First the top layer turned to cool, so the lighter particles have came up and form a thin layer, that is a crust. Then gradually mantle, in which what you call some heavy substances are placed with molten form. Then the core, that is very hot, it has not become cool, right? So the three layers we have seen in the evolution process, and that its distances we have seen. The crust is 100 kilometers depth, then mantle is 2009 kilometers depth, from 100 to 2900. Then the core we have seen from 2900 to 6376, right? In the two parts are there. So if you observe this figure, you will see that it is a red color, the mantle, and the core is a yellowish color. It's very hot. The core is very hot instant than the water mantle, and the crust is not shown here, either red or yellowish. It means it is somewhat a warm temperature we find that is required for our growth and survival, that we have seen internal structure. Then we have seen that next the movements of the continents by the theory called continental drift theory, proposed by Alfred Wegener, right? Who was a German meteorologist and geophysicist. According to him, all the continents are placed at one position, that was called supercontinent Pangea, and it broke into two pieces as the compressional forces generated the Tethys Sea, right? And this was surrounded by a super water body, that is Panthalassa, and it broke into several pieces, right? That we have seen here. You can see that how the continents are moving. My dear students, once you observe that all the continents are at a one place, they are near. And coming to second figure, you'll see there is some movement here, right? And going to the this slide, you will find again there is a gap uh, among the continents. Further, you will see here the continents are moving. And here the important point, you need to understand that what is the direction of the our India, in which direction our earth is sorry our India is moving, right? Can you observe here? India is here, this is India instead. So here you see that where is India, here it is India, right? This India here in this on this earth, it is there in this figure, okay? And coming to this figure, you will see that it has moved to somewhat other place. What is that place, you have to say, okay? Then next you will see here again, which has started to somewhat upward. Again it has moved to somewhat up. Can you guess what is the direction of the movement of the India? What is the direction? It is north west direction. Which one? North. It is in north. Sorry, north. It is east. It is west. It is south. This is north east. Sorry. So in the northeast direction, this in northeast direction, our earth is, sorry, our India is moving, right? So this point you keep in mind, because it will helpful for us to understand the collision of the continents, right? In the next chapter we'll use this point. Okay, so keep in mind. Next we move to the grid system, right? What is a grid here, right? You all have atlases, right? Once you open atlas, you will find different countries, continents, physical, political maps. So if you take India's political map or world's political map, you will find some of the what you call lines drawn across the map, from top to bottom and right to left, right? All those are latitudes and longitudes. We will uh, discuss those latitudes and longitudes in the coming uh, chapter, in the coming class. Okay, so just you keep in mind that the lines which are drawn across the globe horizontally from east to west or west to east are latitudes, and the lines drawn across the globe vertically from north to south, those are called longitudes. So these, so my dear students, we are going to conclude the year as the time is going to complete. Okay, uh, right? Upgrade your meeting. No, it's a time over. We'll see it in the next class, the grid system. Okay, till then you read this moments of the earth crust. Okay, thank you very much.